Shasta High School, and for my starter project, I did a multi-boost charger, which basically takes two AA batteries and converts it to a 5-volt output so you can charge your phone, your iPod, any device. And for my main project, I chose to do the RC tank, and I added a burst to it. So here's a demo. So you can move forward and backwards, you can pivot. And the exciting part is you can fire darts. So how it works is that there are three main components of the tank. There's Arduino, the motor shield, and the wireless PS2 receiver, and with the PS library. So Arduino is a programmable microcontroller, and a lot of projects here use Arduino. And the motor shield is used to drive the motors. I have two motors for the tank tracks. I have two motors for the flywheels. We need a motor shield because the Arduino cannot provide enough power to the motors by themselves. So the motor shield takes care of that by hooking up an external battery charger that can power the motors pretty easily. Also, the motor shield has integrated PWM, so you can easily control the speed of the motors. PWM is a pulse width modulation. Basically, if you want like 50% speed, it switches the current on and off really fast, but the current's only on half the time and off half the time. So it looks like it's continuous, but it's really not. The last important part is the PS2 receiver. And it just receives signals from the PS2 controller and outputs them to Arduino. And I use a library on the Arduino called PS2X, and that allows Arduino to process signals from the receiver, and so I can program the controller. When I press up, it triggers it to the motors run forward. Press down, triggers them to go backwards. I press X, it triggers the flywheels to rev up. So some challenges that I faced were, so I wanted to 3D print a lot of parts because 3D printing is cool and it's the future. So I wanted to use that, but when I came in on Monday this week, iHanger used all the filament over the weekend, so I couldn't 3D print any parts. So I had to improvise and make do with what I had. So I used Depron foam, which is used in the hovercraft. I used a block of wood to mount the flywheels, and I just used a lot of hot glue. It's kind of silly, but it works. So. Another challenge I had was just figuring out logistics of this, how to mount it, how to put it all together, and in the end, I became a lot better at problem solving. So, yeah. Going into BlueSnap, I didn't really know much about engineering because my high school doesn't really offer much for engineering. I knew a little bit about computer science. I took Intro to Computer Science as a sophomore, and I had one experience with Arduino, lighting up an LED. That's really the only engineering experience I had. Going to here, I had a lot of experience. Some electrical engineering, cooking up all the wires, some computer science, coding Arduino, and some mechanical engineering, making the auto loading system. And in general, it made me a lot better at problem solving. And in the future, I think I'm gonna for sure pursue a career in engineering. Questions? Yes.
How do you aim it?
Oh yeah, so you can pivot it. I was gonna make a elevation thing where you could turn it lift it up and down, but I didn't get to that yet. I do that tomorrow. Pivot it and just shoot.
How far can you shoot?
If you angle it, it can go a good 60, 70 feet. On max speed. But flat, it doesn't go that far, it makes that door.
Alright, I won't mess
Yes?
Do you have any ideas for any other modifications you might want to make?
Oh yeah, like I said, so a servo to do elevation so I could tilt up and down. Definitely would adjust the mounting platform because the center of gravity is really high, as you can see. The tank almost flat. It's not that stable. So I'd probably move this lower for sure, so it could be more stable and maybe if I could 3D print parts, it'd be a lot better. The magazine would be a lot better, and the server arm would be a lot better.